cost less to produce, since more fit on a wafer. And wafers are processed and priced as whole, and can help achieve higher yields since smaller dies have a lower chance of having a defect, due to their lower surface area on the wafer. However, smaller dies require smaller features to achieve the same functions of larger dies or surpass them, and smaller features require reduced process variation and increased purity, reduced contamination, to maintain high yields. Metrology tools are used to inspect wafers during the production process and predict yield, so wafers predicted to have too many defects may be scrapped to save on processing costs. 40. Die preparation. Once tested, a wafer is typically reduced in thickness in a process also known as backlap. 43. Back finish or wafer thinning. 44. Before the wafer is scored and then broken into individual dies, a process known as wafer dicing. Only the good, unmarked chips are packaged. Packaging. Plastic or ceramic packaging involves mounting the die, connecting the die pads to the pins on the package and sealing the die. Tiny bond wires are used to connect the pads to the pins. In the old days, 1970s, wires were attached by hand, but now specialized machines perform the task. Traditionally, these wires have been composed of gold, leading to a lead frame, pronounced lead frame, of solder-plated copper. Lead is poisonous, so lead-free lead frames are now mandated by RoHS. Chip scale package, CSP, is another packaging technology. A plastic dual inline package, like most packages, is many times larger than the actual die hidden inside, whereas CSP chips are nearly the size of die. A CSP can be constructed for each die before the wafer is diced. The packaged chips are retested to ensure that they were not damaged during packaging and that the die-to-pin interconnect operation was performed correctly. A laser then etches the chip's name and numbers on the package. Hazardous materials. Many toxic materials are used in the fabrication process. 45. These include poisonous elemental dopants, such as arsenic, antimony, and phosphorus. Poisonous compounds, such as arsine, phosphine, tungsten hexafluoride and silane. Highly reactive liquids, such as hydrogen peroxide, fuming nitric acid, sulfuric acid, and hydrofluoric acid. It is vital that workers should not be directly exposed to these dangerous substances. The high degree of automation common in the IC fabrication industry helps to reduce the risks of exposure. Most fabrication facilities employ exhaust management systems, such as wet scrubbers, combustors, heated absorber cartridges, etc., to control the risk to workers and to the environment. Timeline of commercial MOSFET nodes. See also Defnium. Glossary of microelectronics manufacturing terms. List of semiconductor scale examples. MOSFET MOS. Multigate device FinFET. Semiconductor industry foundry model. Semiconductor equipment sales leaders by year. International technology roadmap for semiconductors. Semiconductor consolidation. Local oxidation of silicon, locus. List of integrated circuit manufacturers. List of semiconductor fabrication plants. Microfabrication. Semiconductor Equipment and Materials International, SEMI, the Semiconductor Industry Trade Association. Semi-font for labels on wafers. Etch pit density. Passivation. Planar process. Transistor count. References. Neurotechnology Group, Berlin Institute.
Good. I did finish read this. This need to go to my read again list. I have my computer read list down there. but I think we should read about the waffles. But there's a lot of links. I will have to look this document through the Wikipedia. But that's too many links. We cannot read everything because then I have to spend 1 month or 2 months to read all this PDF. But I like to put view down. It's 12 noon. I'm having news in 12 noon news in 10 minutes. So I will take a break and charging my camcorder. And then I will read the next one.